Hey guys, today in section 6.5, we're going to go over the rules of logarithms. We'll go over a few examples of how to apply the rules of logs, and then we'll go over how to find a logarithm even if it's not on your calculator using the change of base formula. So the first rule of logarithms is the product rule. And the product rule tells us that if we have log of a times b, then we can rewrite this as the log of a plus the log of b. And so going from the left side to the right side is called expanding the logarithm. So if we were going from log of a times b to log of a plus log of b, we call that expanding the log. And hopefully that's clear to see because we're taking one log and breaking it up into two. It's taking up more space, so we're expanding it. And if we were to go the other way, we call it condensing because we're taking the two logarithms and writing them as one logarithm. And so this product rule of logarithms should be hopefully somewhat familiar. Maybe it reminds you of something. And it should remind you of the exponential product rule, which says that x to the a times x to the b is equal to x to the a plus b. So this is the logarithmic equivalent of the exponent rule for exponents, or sorry, the product rule for exponents. Notice we're multiplying two exponents, and what do we do with the powers? Well, we add them together. And so here you can see that we're multiplying two arguments of the log, and that turns into addition. So hopefully you can use the rules of exponents because you're probably more familiar with them at this point to remember the product rule of logarithms. Okay. The next rule of logarithms is called the quotient rule. And the quotient rule tells us that if we have log of a over b, we can rewrite it as log of a minus log of b. Okay? And so this works just like the product rule. Going from left to right, this is expanding the logarithm. And going from right to left, this is condensing it. Okay? And what should this remind you of? Well, this should remind you of the quotient rule for exponents, which tells us that if we have x over a, x to the a over x to the b, this is equal to x to the a minus b. So very similarly, when we have some division, it turns into a subtraction of exponents, right? We subtract the powers. And the same thing applies to logarithms. If we're dividing inside the argument, then we can rewrite it as the difference of the logarithms. Okay? And the third rule is the power rule, which tells us that if we have log of a to the b's power, then we can rewrite this as b times log of a. And just like before, we have an exponential equivalent of this, right? Log of a, log of x, not log, x to the 8th power to the bth power, right? Raising this exponent to an exponential power gives us x to the a times b. And so if you're raising the argument, whether the b is in here or in here, because there's only one term, it's going to be the same thing. This will be different when we have multiple terms in here, but if we have an exponent raised to a power, it's the same as the product of those two powers, right? And so this is what's happening here. We have the argument being raised to the power b, and it's being equal to b times the log of a. So let me clarify this. Why did we have the b out here, and why did I move it inside? Well, in this case, it's not going to matter, but let me show you an example where it does matter. So, okay, if we have log of, let's say, x to the second y. Okay. Here, since we have two things being multiplied, this exponent for the x, this 2, that's the power of the x, only applies to the x. So we wouldn't be able to use the power rule right away and give, and let's say, so this is not true, but we wouldn't be able to write the 2 out in front using the power rule. Because why? Well, because the y is only to the first power. But if, for instance, instead of the 2 belonging just to the x and it belonging to the entire argument, then we would have this equivalence, because we could put that 2 to the x and to the y, right? And then we would be able to give the 2 to the entire logarithm. So we'll go through two quick examples here, one with expanding logarithms and one with condensing them. So let's go ahead and work on the expanding logarithms. And so when we talk about expanding logarithms, generally we're starting with one logarithm and expanding to multiple logarithms. When we talk about condensing logarithms, we're going to have multiple logarithms and we're going to try to squeeze them, condense them back into a single logarithm. And notice that you can only do this if the bases of the logarithms are the same. So when we spoke about all of our rules, you'll notice that the base of all of these logarithms is base 10, right? So that's why these rules apply. But if you have the case, for instance, log of 2 of x plus log of 3 of x, and we can just change this to y, this is not equal to log of x times y. And why is that the case? Well, because their bases are different, right? So, well, what would we put as the base here? A 6, right? So we can only use these properties of logarithms if the bases of the logarithms are the same, okay? So just remember that. There may be questions in the textbook that try to trick you into using the rules of logs when they do not necessarily apply. Okay, so here we have log of b, argument 6x squared y. And so typically what we're going to try to do is, when we're expanding logarithms, we're going to go from product rule, then quotient rule, and then if we have it, then we'll do the power rule. Okay? If we're condensing logarithms, what we're going to want to do is apply the power rule, then the product rule, and then the quotient rule. Okay? So just keep that in mind. And so for the expanding logarithms, we want to break this up into as many logs as possible. We're going to try to make it take up as much space as we can. And so first we see we have 6 times x squared, right? So, well, we have two things being multiplied together, right? A product. So we can break this up into logarithm additions. So we can take log b of 6 times x squared, which would give us 6, right? Plus, and then the second term we have, which is x squared over y, right? And so this is because I broke it up into 6 times x squared over y. And so now we're going to have the sum of this being the argument of the first log and this being the argument of the second log. Okay? All right, so, well, there's really nothing left to do in the first log, but if we look in the second log, we have a quotient, right? We have x squared divided by y. So we have x squared divided by y, and that tells us, right, that we can break this up into the difference, right, using the quotient rule. So I'm just going to bring the first part down, log b of 6 plus, right? And because x squared is on top, this gets the plus log of b of x squared. And the quotient rule tells us to put a subtraction on whatever is on the bottom. So log b of y. All right, well, do we have anything left to do? Okay, yeah, look, we still have the product rule to apply. So, well, the first log, there isn't much to do, so we can rewrite that one. And what happens when we have the argument raised to a power? Well, we can bring it out in front, right? Make it multiplication. So this will become 2 log b of x, right? The exponent is now in front. And then minus log b of y. All right. And so we can check one more time. Is there anything left for us to do? Doesn't seem like it. So we are good. So we've expanded our original logarithm as much as we possibly could. All right. Now let's look into condensing the logarithm. So here, what we want to do is we're going to use all the rules that we have, the product rule, the quotient rule, and the power rule, to put this into one logarithm. And so, well, what do we need to do that? Well, we need the coefficients in front of the logs to all be the same, and we need the bases to be all the same. And so we have all the same bases, but what we don't have is the coefficients out in front of the logs to be the same, right? The coefficient of this log is 1, the coefficient of this log is 1/2, and the coefficient of this log is 3. So the first thing we're going to do is apply the power rule to move these coefficients up to the power of the argument, so we don't have to worry about the coefficients being different. And well, since this is a 1, there's really not much to do here, so we're just going to have log 2 of x squared plus, and so we have a 1/2, so we can change that to the power, so log 2 of x minus 1 to the 1/2. And then this 3, we want to also push this to a power, but we have a power, so we're moving a power and we're multiplying a time of power, so we're going to get minus log 2 of x plus 3 to the 6th, right? Okay. And now we're going to apply the product rule if we see it, and then the quotient rule. And so we see the product rule because we have addition, right? And so this is using the product rule backwards in a way. When we have the same bases being added together, we can change it into a product. So this becomes the log base 2 of x squared and then times x minus 1 to the 1/2. Okay. And hopefully we can remember that when we have a fractional exponent, this is the same thing as a radical, right? So we'll rewrite it one more time. Log base 2 of x squared times the square root of x minus 1, right? 1 is the power of the argument here, and the 2 is the power of the radical. So it's going to be a square root. And then minus, and we'll rewrite the second logarithm because we haven't done anything with it yet. And now here we can apply the quotient rule because we have the same base being subtracted, and so we can turn this into division. And so we have log 2 of x squared times the square root of x minus 1 all over x plus 3 to the 6th power. And so we are done because we've condensed our 3 separate logarithms, right, of the same base to one logarithm. All right, and there's one other thing from this section, but it's a pretty short section in general in terms of what we're going to learn, but there'll be a whole bunch of different types of problems you'll see. These can get pretty tricky. All right. And so the last thing in this section is the change of base formula. And so what is the change of base formula good for? Well, the change of base formula helps us to calculate logarithms that aren't necessarily on our calculator, because sometimes we may need a calculator to determine exactly what the value of a logarithm evaluates to. So if you look on your calculator, if you're already familiar with it, there are basically two types of logarithms that we have on our calculator. We have log, right? And this, if we don't write it, it means log base 10. Okay, and we have the natural log, ln. You may see something like this on your calculator. And so on your calculator, it may just say log, and it may just say ln, but log, right? Log tells us the base is 10, and then the natural log, ln, tells us the base is e. Okay, so it's that number that's kind of like pi, but isn't pi. Natural log is log base e. And so these are the only two logarithms you have on your calculator. And so what would you do if, for instance, you were trying to figure out what this evaluated to? So let's say we had log base 2 of 7, and we wanted to figure out, well, what is this equal to? And so if we used our changing logs to exponents rule, well, we'd have 2 to the y is equal to 7, right? By saying log base 2 of 7, well, that's equal to, log base 2 of 7, well, that's equal to something. And we take the base, raise it to the answer, and it's equal to the argument. But this isn't a nice one because 2 and 7 are relatively prime. We can't change 7 into having the same base as 2. And so, well, we know this number is between 3 and 2 because 2 to the second is 4 and 2 to the third is 8. So we know it's somewhere in between there. But what if you wanted to calculate and see what this log actually evaluates to? And so what you do is you use the change of base formula. So if you have a log like the one we've written here, where we don't have log base 2 on our calculator, this is the same as writing log base b of 7 divided by log base b of 2. And so I've written b, but this just means it's kind of dealer's choice here. You can choose whichever logarithm on your calculator you want. You can do natural log of 7 divided by natural log of 2, or you can use the log base 10 if that's one you're more comfortable with. Log base 10 of 7 divided by log base 10 of 2, and that is the change of base formula. So for any log base b argument a, you can change it, evaluate it as log base c of any other log of the argument a divided by that same base log over b. So basically, the argument is the numerator and the base is on the denominator, and you do division. And let us quickly do that on a calculator and see what kind of value we get. And so we have natural log of 7 divided by natural log of 2, and we get, well, it's 2.807 ... right? And so we'll do little squiggly lines. And remember, we said that we knew that this value was somewhere between, right? Y was somewhere between 3 and 2. And look, the value that we got is somewhere between 2 and 3. So we can kind of, check ourselves mentally that we got something that we thought the answer might be. Okay. And so that's basically all for this section, and I'll see you in the next video.